In our next problem, we are given with the standard heat of formation of HgO at 298 Kelvin and constant pressure is minus 90.8. So what is happening is mercury is combining with oxygen to give HgO, and we are having the excess HgO absorbing 41.84 kilojoules of heat at constant volume to decompose back into liquid mercury. We need to find the mass of mercury obtained during this process. So first of all, we write the heat of formation equation for HgO. The elements have to be taken in their native state. So mercury in liquid state plus oxygen in gaseous state to give 1 mole of HgO in solid state. The delta H for this reaction is given to be equal to minus 90.8. Now since we are concerned for the reverse reaction, which is the decomposition of excess HgO into mercury, we reverse this equation to get liquid mercury and oxygen gas. The delta H for this reaction is very obviously the negative of the original delta H, which is equal to 90.8. But since this reaction is getting carried out at constant volume, so we are not concerned about delta H, rather we are concerned about the delta E part. And we know that delta H and delta E are related by delta H is equal to delta E plus delta NgRT. So delta E is equal to delta H minus delta NgRT. Now what is delta Ng? It is the number of gaseous moles in the products minus the number of gaseous moles in reactants. Here it is only oxygen gas is the only gas which is involved in this reaction. The stoichiometric coefficient is half, so delta Ng is equal to half. So delta E is equal to delta H, which is equal to 90.8 minus half into R minus half times the R, which is 8.314 into temperature, which is 298, and since this part was in kilojoules and this part obtained is in joules, so we multiply this by 10 power minus 3. We have calculated delta E because the second part of the decomposition of excess HgO was carried out at constant volume, and hence we are concerned about delta E and not delta H. So on solving this, we get delta E equals 89.56 kilojoules. And we know that for the above reaction, the excess HgO is absorbing 41.84 kilojoules of heat. So the number of moles of mercury obtained are 41.84 divided by 89.56, which is equal to 0.4672 moles of mercury. And we know that 1 mole of mercury amounts to 200.6 grams, and hence the mass of mercury obtained is 200.6 into 0.4672. On solving, we get this equal to 93.71 grams, which is the final mass of mercury obtained.